Okay, so we're officially recording on January 22nd, our first data science class. This is the first time I've ever taught this class, so I'm going to talk about what it is, and then we're going to kind of get into a little bit of the GIS because I hear early childhood education. Most of the other folks should have some experience with the GIS, so we'll get kind of Cameron caught up. We'll make sure Dolores can kind of get logged in and all that other good stuff, and we'll talk about what this means because I think we're going to hit the ground running with some of the things that we did last semester in geostats, interpolations and workflow models. And I know Andy's kind of new with getting used to ArcGIS Pro. And we've got another, Eric was GIS, but took the old version of GIS pre-pandemic. So using something called ArcMap. So we've got Travis, we've got Andy, we've got Tony, Barbara, Caitlin's joining us online. Casey, I don't know where she is. Moni, she's online. Ibrahim, he is joining us online. Daisy's in the back. I know Daisy. I know Lauren. Alexis is joining us online. We've got Mac. Jerry, can you hear me? Thought I saw a Jerry on here. Nope. Oh, Jerry, can you hear me?
Oh yeah.
Yeah. What's your major, Jerry?
Mass comm.
Oh, cool. Oh, mass comm. All right, interesting. Good. Okay. Mass comm. Victory wasn't able to join us. Diamond contacted me. Ariel, Favor. We got Chima, Deja, Marlene, Sarah, Chantel, Cameron, Dolores, Nyanda is an online student, I think, and Benjamin. Okay, it looks like he logged in here. Okay, so this class here, and we kind of go to our dashboard. Thanks for bearing with me. 2 weeks ago, I was at the Transportation Research Board Conference, which is the largest meeting of transportation professionals in the world. And so a lot of times, what does mapping have to do with transportation? A lot of things. And so we took a student who created some drone imagery up there. And we got funded by the NCDOT and the FHWA, Federal Highway Authority, to take students up there, or take a student up there as part of the Minority Scholars Program, where they got paid to do networking and a lot of neat things. And this is about the fifth year that we've done it, and it's a really kind of great experience. But it's usually the first week of January, which is really cold for Washington, D.C. So are there students that are interested in doing something like that? I know you're from up there, so that would be like real, like low hanging fruit. You go up there, go hang out at home and do some neat things. But students need to write a paper over the summer and then submit it to the TRB for acceptance. So this is a real kind of good opportunity for us to get out there and us to get, NCCU to kind of be noticed out there as part of transportation, because we have students who work downtown, do a lot of neat things downtown, which I'm really encouraged by. So I'm going to talk about a couple things here, introduce the class, talk about what this class is supposed to be, what I think it's going to be, and then kind of go through the syllabus and start getting into working with, getting back into some ArcGIS Pro. And then next week, we're going to get into some programming. I use the word programming, people get really, really scared. So we're going to be using this programming language called BASIC because it's basic. And then we're going to start working with something called Python, which is the scripting language for our GIS software. So today we're going to introduce, ArcGIS Pro. We're going to talk about automation and workflows. Does that ring a bell? Yes. All right, good. We did a little of that in 4010, but automation and workflows. And this first assignment that we're going to talk about this week, it won't be due until the end of the semester. Guys, I know there's going to be a little bit of a learning curve with some of the folks who haven't taken GIS before, but I'll expect some of the folks coming from geostats to kind of, I remember this, I'm going to do this, and we're going to kind of move on to bigger and better things here. Recently, we moved over to Canvas. And so those of you who know my classes all look kind of the same here. So I've got my instructor information. I've got class resources up here. It looks like I haven't posted my syllabus yet. So I'll talk about the syllabus a little bit here and what my plans are for this class. and as we kind of move forward here. So right now, this is my syllabus. But this syllabus, this syllabus is called 5320. This is also offered as an undergraduate class, 4320, and it's called Applied Data Science for the Geosciences. This used to be programming and logic for the geosciences or something like that. And we wanted to kind of expand it a little more to include data science because that's kind of a big hot button topic. And we'll explicitly talk about different types of geoscience data. In week 7, we'll kind of look at, data wrangling, all those other things here. So this class is going to serve as an introduction to data sciences, how they can be applied to the data science, to particularly the geosciences. And within our department, environmental, earth, geospatial sciences, and we're the GIS component of all that. We're going to mainly talk about Python, a little bit of R. VBScript is kind of a scripting language for web pages, but we're going to talk about programming and how to run programs. A lot of people get scared about those things here, so I'm going to kind of ease it in nicely and neatly, and my expectation is you're going to kind of look at one of these things and take off with these. One thing about me, I'm not a programmer, but I'm good with data and I know enough programming stuff so that I can pretend to be dangerous to do some of the things that I want to do. And so some of the things with programming we're going to do in this class is we're going to introduce some modules here, some of the code that I've written, and we're going to cater it to do some of the things that we want to do. And so you have a question? Just point. Okay. And so you can see some of the various data types here because these days data science is the whole idea of turning information into some formalized format. And these days when I go spend money on anything, we make decisions. We watched the football game last night and they're going for 2, even though they're down by 8. I don't even know why they did that. Remember they were watching the football game and, Buccaneers went for 2. Why'd they go for 2? I have no idea. Because these days, when we talk about whether it's sports or decisions or location, what do we make decisions based on? Data. We know this person is batting, 363 with runners on second and third or whatever. And we have so much data that we just base it on prior decisions. The days of I feel like this is a good idea, I think, they're gone. And so what we talk about is facilitating data-driven decision-making. We're going to talk about data in all its ways, shapes, and forms. And I think a good part of this class is going to be focusing on a lot of the soft skills in terms of marketing yourself and some of the challenges and how to get into the workforce. I think a lot of times there's a big schism between people like me who have had jobs before and you getting your first job and getting out there and presenting yourself professionally so we can kind of hit the ground running. Because at some point in time, no one's going to care about what your grades were. What are they going to care about in the job market? What was your last job? What was your job before that and your job before that? And so really the project that we're going to do for this class is really taking off with one of the topics in this class that we learn amongst all these different topics and you being the expert at it. I just hosted a graduate student meeting for all of our grad programs because I'm the graduate coordinator and my main goal is you be better than me at something in this class. I don't know what, and hopefully we can go and find that niche. There's a lot of kind of disparate data sources out there. We've got COVID data. We've got ACS data, American Community Survey. There's tons of climate data. We can go to the EPA webpage and start downloading stuff at the kind of zip code, county level. And when you start thinking about data, it's just gigantic Excel spreadsheets or CSV files of thousands and even millions of records. And we got to make some sense out of it because I want to just turn it into a nice, pretty map that I can show a 9-year-old or a 90-year-old and then make sense of it. And I think that's what our goal for this class is going to be, especially in the second half of class when we kind of get away from the programming and start talking about some of the automation of processes and what are some things we can do to turn big, gigantic data sets into something that people can understand to facilitate data-driven decision-making. So this class meets Monday from 5 to 7. It's going to be a combination of lecture and lab. And like I said before, this is the first time this class has ever been taught. So my goal is really we open up the software, we log in, and we start working together. And so people following us, and I record it, it's gonna hopefully be kind of, we all work together. So me doing a song and dance and everything else is gonna, I'll talk for a little bit, and then today we're gonna open up ArcGIS Pro, and hopefully everyone will be able to log in, open up the first exercise, look at some data, look at some interpolation, and maybe take off with that first exercise. And the next week, I've installed the software on all these computers to do programming. Very basic programming. Hey, let's just list numbers from 1 to 10. Let's add them together. Let's do some times tables. Hey, let's take two numbers and run the quadratic formula. Does everyone know what quadratic? Okay, good. Remember that negative b plus or minus square root of b squared minus, all that good stuff there. Okay, if statements. What happens if the stuff under the square root's a negative? What happens when you get negative square roots? Really bad things happen. Computers, they don't explode, but really bad things happen. So what do we do to circumvent some of those things? And so those will be some of the things that we talk about, so we can integrate these into some of our maps. And so instead of me typing in two numbers, hey, we're going to input a feature class or a field or whatever we want to do. So this is my office hours right here. Typically, I won't be on campus either Tuesday or Thursday, but typically not both. And so tomorrow is going to be the day that I am not here. I got to take my kids over to school, but in this class, we're going to have a project worth 100 points. We're going to have lab assignments worth 10 points each. And then we're going to have a final exam. And then for students taking this as an undergraduate class, you will not have a final exam. So it'll just be a project and 10 lab assignments. So pretty straightforward here. I always kind of make the recommendation, hey, if you want to take this class as a graduate student at some point in time in the future, go take the final, so that when you sign up for it in a year or two from now, I'll just give you whatever you got in this class and give you the same grade. And so we do that a lot of times with geostats, so you don't have to take the same class twice. You'll just apply what you got onto that class. In some cases, a couple of students last semester, they had to write the paper who had taken it as undergraduates. And so I can be happy to work with everyone here. We have attendance, exams, labs, and like I said before, the project is we're going to apply the skills learned to basically create like an online resume statement, and then you're going to record a video. We're going to use something called Esri Story Maps, where you're going to make an online resume that you can send to an employer and say, this is what I've done. 12 to 15-minute videos, statements, some of the things that you've done to kind of highlight and articulate some of the soft skills that we're trying to pick up as part of this. During our previous talk here at 4 o'clock, we were talking about something called GERS, the Graduate and Undergraduate Research Symposium. And so this is something that you submit at around campus. So maybe in the next week or so, maybe I'll look at some ways that you can present at GERS instead of having to take the final. And so just get some more of these presentation opportunities, because I don't want to grade finals or write finals, and I'd rather see you all present than me have to do this. And so we've got some Esri exercises. These are some of the Esri exercises that we're going to kind of talk about here, but these will be integrated into the exercises. So we're going to talk about access to ArcGIS Pro. I think most people here that I'm looking at have access to ArcGIS Pro. Those of you joining us online, we'll get it installed. We'll get the tutorials. We'll get all those things going, because we're going to circle back to ArcGIS Pro in about 3 or 4 weeks. Because next week we're going to start with programming and small basic, literally just tiny little programs for those of you who've never written code before. For those of you who to write code before. And so I think a lot of times people get really scared when I say the word programming. Is anyone scared about programming? A little bit. Okay, that's okay. Nothing wrong with that. We're going to start real, like literally basic. Programming language is called BASIC, and then we'll work from there. And when we do these things, when we write a program, what are we doing? We're just automating. Instead of me going over and clicking a button and pointing this and doing this, there's a line of code that does that. Now, you're not going to write the code here. And what we're going to do today when we automate workflows is that ArcGIS Pro is going to convert all that stuff to Python, and then I can just kind of customize it the way that I want. And so to be honest with you, when you start working in ArcGIS Pro, you're never going to write a program from scratch. we're gonna work on these workflows. I'm gonna give you some little snippets of code right here to do the things I'm used to. Then you just customize and automate it to do what you want to do. And so I really encourage people to work smarter instead of work harder, because anything that you're going to want to do, someone has already done before. And so you find what you want to do, and then we can kind of cater it to what we're doing here. And so you'll see some of the things that I've written before in Python, some of the small little programs that I've written in BASIC in Python, and we're going to look at something called R, which is a statistical programming language. And that's got its own user interface. So I want to just very kind of, dunk into some of these kind of programming languages, get you an exposure and give you the opportunity to really take a deep dive into some of those here. Anything with student disability services, just please let me know, are there any accommodations that need to be made? Academic honesty, all these other things, just make sure everything you submit is your own. We're going to be working on these relatively small projects right here, and then these are some of the dates. But this is kind of what I'm looking at right here. This is probably going to change right here, but this week we're just going to talk about ArcGIS Pro modeling and workflows, and I've got a little presentation, and then we're going to go and open up ArcGIS Pro, make sure everyone can open it. Some of this might be pretty easy, and talk about automating workflows. Meaning, well, I want to click on this and do this, because a lot of times, and what are all the buttons you got to click? Well, I don't want to remember all the buttons. I just want to drag them all somewhere and do it once. And then next couple weeks, we'll talk about basic programming, just an introduction to programming, what's input, what's output. And then we'll talk about Python for a couple weeks, and then we'll talk about the R programming language. We'll talk about transition to open science. Has anyone heard that term open science before? I know Chima has. Basically, when I get a grant and I create all my data, where does it sit? I do this really cool project. Where does it sit? It usually sits on this thing right here, and it just stays there, and it lives forever, and it never gets shared. And so there's a lot of these open science initiatives that you need to share your data. So if you get a grant, and we have a grant from NASA, we've got a grant from NSF, and we've got another one from USDA. They're starting to require that all of our results and all of our papers and of all of our kind of non-proprietary data that doesn't have personal information gets published. And so we're going to do some transition to open science. Previously in geostats, we talked about hypothesis testing. My big thing is, what are you trying to prove? What statistical tools are you trying to prove? What are some of the tools, methods that we talked about last semester? I'm trying to make eye contact with people who took the class last semester. Barbara's not looking at me. She's looking right next to me here. Benjamin, what were some tools that we talked about last semester? What were some tools that we used for proving statistical hypotheses? What is one of the big ones we've taught? The red and the blue, what are those? Hot spots and cold spots, right? Yes, hot spots and cold, very good. So we got hot spots and cold spots, meaning hot spots, high areas surrounded by other high areas with what? With statistical significance. We had two-tailed t-tests, because a lot of times we pull out our phones and we see these gigantic facts here that really aren't proven using statistical methods. So we talked about some of those statistical methods. We can see the poster in the back right in front of Tony, where Michael who's working over at NCD EPA or something like that. He made a hypothesis that said areas around chicken processing plants have higher COVID rates than areas outside of chicken processing plants. Just totally spatial in nature. Now, why? I don't know. We'll leave it to someone else. Maybe someone looking at us online, someone interested in sociology or nutrition sciences or whatever. I don't care. But these is truly spatial in nature. And so what are some of the tools? We got two-tailed t-tests. We looked at ANOVAs. Obviously, we've got the descriptive statistics, mean, median, mode, and then we kind of got into some things with clustering, nearest neighbor analysis. My big go-to tool is two-tailed t-test. What are you going to say? Kriging, yeah. Kriging, splining. We'll get into those a little bit today. Kriging and splining to create interpolated surfaces. But my go-to tool, two-tailed t-test, quintiles, ANOVAs, clustering a little bit, okay? And so make sure, and hopefully we'll get to a point in time where we can equip you with some of these go-to tools that we've had. Hopefully you remember some of those. Other thing we'll talk about is data wrangling. Dr. McGinn and I had a paper, and hopefully we'll post all of our papers where we wanted to map political affiliation by zip code. Do you think there's a map out there of that? No. So we have a list of every single registered voter in the state of North Carolina. How big of an Excel spreadsheet do you think that is? It's really big. Okay. It's like real big. It's about 8 million, 6 million records, 7 million records. And then we can see how many people voted last year. Now, when you open up 7 million records in Excel, what does Excel say? We don't do that. Okay, so you got to use something like R, and actually there's something called Power Query Editor in Excel that does that a little bit better, but it summarizes those things. And so we can run some summarize, but open up 8 million records. COVID, for 2,000 zip codes. Voter records. We've got 5,000 different latitudes and longitudes out there that we want to map. So we're going to talk about ways with this data wrangling to talk about all these different data sets, because a lot of times when you come to me and say, I want to map this, I want to do a project on this, my first question is going to be, where are we going to get the data from? What are we going to do to it? And this is where I got my start in GIS when I worked for the military, 20 some years ago, was I make these cool maps of power lines, training areas, roads. And my first question is always, where are we going to get the data for? Am I going to download it? Do I got to do GPS it? Am I going to, extract it from satellite imagery? Where are we going to get it? There's a lot of great data sources out there. And last semester, where'd you get all your data from? Me. Here's some health data. Here's some cancer data. And we're getting to a point in time where you're going to be the one to turn this into powerful GIS data. And hopefully with data wrangling, we're going to deal with that. Things like the vital statistics database. We have things called data cleaning, which basically means you've got a bunch of nulls in your data. Who wants to go through and check how many nulls are in all this stuff? I don't want them, So we can write a little bit of Python code that goes through and says, hey, wherever it says null, I'm just going to put a value in there. Okay, really, really simple Python code that does this. And then another thing with metadata, I did my PhD dissertation on metadata. Okay. Is anyone familiar? What is metadata? Data about data. So you have separate files stored as XMLs or within the database about the file. There's about 400 to 450 individual elements about a GIS data layer. Who created it? When did they create it? Why would I want to do my dissertation on metadata? Why would someone be so... Why would I want to do that? That's what I did it for my job at the military. So I did my job at the military. I didn't want to go invent something brand new to do. So I did my PhD at UNCG and said, you know what? I'm going to do my dissertation on the stuff that I spent the last 6 years working on and just turn that into a dissertation. So I encourage people to work smarter as opposed to working harder. So if you've already got an interest from some of your projects that you've already been working on, let's figure out ways that we can integrate data science, programming, all of these things into that, so we're not kind of relearning things. We got some deep learning algorithms that we're going to talk about here. And then, like I said before, we've got a relationship with NASA through a grant that we got a little less than a year ago. And so they've got a lot of AI, ML training tutorials that are above me that are really good. So I think we're just going to kind of unleash those. And then we also have something called TOPS, Transition to Open Science, training through NASA. So they've worked really hard to facilitate some training for us to kind of fill in the blanks for what we do. Because this class isn't really data science, it's data science according to me. So what I think data science is going to be. Some of the things that I do, working with the North Carolina voter statistics database. How do we turn all those 6 million records into something on a map that we can look at? Even mapping, 6 million records, that takes hours to do. So, how do we do that? COVID, we go and download all the COVID data. How do you turn that into something usable. You know, we got the joins, we got the summarizes, we got the relates, and I think a lot of those folks in the back kind of nod their head, hey, I remember some of that stuff. And so we're gonna work on kind of how do we turn just this massive amount of data sitting out there into something. I think I did post a paper here about cancer rates. We had a PhD student who were mapping cancer rates over the last 20 years, where they were looking at female African American cancer rates compared to other races. And so we had 20 years worth of deaths. You can go and download a database of every single person who dies on a yearly basis. About 100,000 people every year. Times 20 years, you got 2 million people who die. Just a big Excel spreadsheet that we turn into GIS data. And we have field names, and those field names change from time to time. And so it's just not a matter of cutting and pasting, cutting and pasting, cutting and pasting. It's a lot of nasty things that we got to figure out there. And so I want us to be equipped in developing some of those data. And in the meantime, hey, let's look at a little code so that we can make sure this stuff is good or manipulated as well. So I kind of look forward to some of those. And then we got our final exam. Maybe if I have the gumption here, I'll just say, you present at GERS, you don't take the final, get 100 on the final. I'm not going to lose sleep at night if everyone gets an A, and we kind of, and you learn something. That's the main, the main thing here. Take something from this class. Some of my favorite classes that I took as a, graduate student, undergraduate was too long ago, but as a graduate student is that I really kind of took off with something. I took a geostatistics class. The professor wasn't all that great, but so I had this whole field of geostatistics I never even knew existed. We got clustering, we got means, medians, modes, all the stuff that you can do to numbers. You can also do to spatial data with an added dimension. And so really kind of keep your eyes and ears and mind open for some of the things that we can do here, because we're going to kind of sit down. I'm going to give my little spiel, and what we're going to do is we're going to open up the first exercise and start working with this, start working on exercise 1, see if we can model some workflows, and hopefully I'm kind of looking at folks here, make sure we remember some of the geostat stuff we did, because we're going to revisit a lot of that. Cameron, you're going to be new. Dolores, this is, you'll be familiar with it, but it might not be the exact same thing. But other people are like, oh, I better remember. I better remember my login. Oh, I forgot how to log in. Okay. And then those of you joining us online, I've posted the GIS software. I want to make sure everyone can log in to the software. Most of you here can. Better be able to, rather. Okay. Other folks, I'll help you. I'll help you get logged in here. So, any questions about how the class is going to work? We got 10 exercises. We're going to have a project at the end where you're going to make a video, and it's also going to be peer reviewed, meaning the other people are going to review it where you take off on some topic here. And also, as part of this class, I really want to focus on some of the soft, kind of hot button topics out there. I think one of these weeks my wife is going to come on. We're going to talk to her because she is a female in a male dominated profession, and it's just some of the challenges that people have in terms of how do you go from here to kind of working out there or going on to your PhD and being successful, because a lot of it's not related to grades, and so what are the differences between the kids, the students who are kind of getting out there and the ones who aren't. And I want to make sure you're all the ones who are out there working for the city or working downtown or, texting me for a, reference, when you're 25 and making 6 figures. We have students who do that, to these days, and kind of get you in a really positive trajectory. So I want to make sure we kind of cover some of those things, cover some of my papers and everything else. Any questions for me? Yes, Mac.
Will this include building dashboards?
No dashboards whatsoever. If you wanted to build a dashboard for your final project, I would love that. Have you done dashboards before?
No, but it's something that me and Ben were working on in Texas.
Okay. Yeah, dashboards would be great to display it. Yeah, that's real. I haven't done too much work on dashboards, to be honest with you. So, me, and we're going to talk about the intersection of my interests here using kind of an interesting little graphic, and then we'll kind of, get started here. So when we talk about data science, this is kind of my little spiel here. Usually in geostats, it's lots of slides and stuff, but this one isn't going to be as much. And then we'll kind of just get started. I want to make sure everyone has access to the software. Everyone can log in. Everyone can get onto the computer. So that's about most important to me. But the one thing about these days, in this day and age, there's massive amounts of data being created. And the whole idea of datafication, meaning taking all aspects and turning them into data. We have information. Again, when we turn information into some formalized format, that's what we call data. Today it was 62 degrees out. Okay, that's information or fact or whatever. But when we put it into an Excel spreadsheet or put it into a spreadsheet and list it here so that it can be mapped or analyzed or whatever we want to do to it, that's what we call data. And so there's an abundance of inexpensive computing power and communication capacity. And I talk about that arms race between how fast can we process stuff versus our size, the size, storage size. I've got this little flash drive right here that I'm recording, or external hard drive. That's 1 terabyte. My first computer I bought, which was like a big kind of tower, was 8 gig. I lose 8 gig flash drives in my dryer all the time. I do. And so we've got this arms race between those. And I'm teaching a drone class where that in the drone class, we're going to deal with that arms race there on Wednesday when we start processing. It was probably a couple gigs worth of data on using the Drone to Map software, and we're going to just kind of sit there and see what it looks like. And that's kind of where these things butt heads. And it's difficult, if not impossible, for people to kind of assess and evaluate those. And so we've got the proliferation of low power sensors like the Internet of Things, but this is kind of some neat things with data science is the blend of kind of Red Bull fueled hacking and espresso inspired statistics. And like I said before, this is my version of data science. And so it's going to be a little bit of metadata. It's going to be a little bit of programming, a little bit of data wrangling, and kind of filling in the missing blanks from what we learned in the textbook, where we did geocoding, we did this and we did that, where Mulrooney says, all right, cool, that's a cool project on chicken processing plants or ADD or ulcerative colitis deaths. Where are you going to get the data from? Good luck with that. And that's kind of what I want us to do. Or, hey, I got a bunch of null values here. Or my boss wants me to see how many null values are in 1 million records. Who's going to go count all those? I'm not going to. You're not going to. That's why they invented No, I'm just kidding. That's why we invented Python code to do that. And so data science isn't statistics, because statisticians finish theorized perfect model. But what we try to do is kind of fill in the blanks so we can turn data into information and facilitate decisions here. And so a couple things here. Individual data science profile merged into data science team. And in this class, we're really going to focus a little bit more on the geospatial data science so we can make decisions. Okay, put these things on a map, stick these into ArcGIS Pro, and when we open up our first project, you're going to say, oh, wow, there's a lot of dots here. How do we make sense out of all this stuff here? We're looking at deer vehicle collisions. We're looking at schools. I zoom out, it's just a bunch of red and green here. So it's going to be a little bit different than the nice, pretty projects that I give you in 3435, where the map's all ready to go there and it's nice and zoomed in. Where that, this is just going to be bits and pieces of answering some of these large questions here. And so there's a lot to data science here. Like I said before, we've got a little statistics. I don't want to rehash what we did in geostatistics or revisit that. And so we're going to talk a little bit of programming, and then hopefully you'll take off with that. And then we'll talk some metadata, some big data. A lot of times you hear this term big data. These are like 6 million records of people, registered voters in North Carolina. You're going to have to, ArcGIS Pro might like it, maybe not, but Excel is not going to like something like that. And so we've got the different actors within there, because at the end of the day, your boss isn't going to care about 6 million records of Power Query Editor or R. they're gonna wanna look at something interesting that they're gonna give to people to facilitate data-driven decision making. And so data developers focus on software to do statistical, analytical, machine learning tasks. We'll talk a little bit about the machine learning or artificial intelligence on this. I'm not super great on it. Tony has done more on the AI stuff, right? Is that what you did a little over the summer? Where we're working to develop, how do we use AI and ML to extract features? I think it was trees, if I'm not mistaken. Extract trees from imagery that we're capturing using drones or from some of the existing things. So what's the shape here? And we're actually doing a little bit of it with our drone today, where that we were doing something called a point of interest or POI, where that we were taking pictures or images, capturing imagery of the Dr. Shepherd statue all across the street. We're trying to zoom in to his head there so we can zoom around. It's like, I don't see his head. I don't see his head because I don't know why, I'm not sure why. And so it does some of these different clustering techniques. So we just focused on this big bunch of bricks right there, right next to it. That was consistent. So there's a lot of different types of geosciences, but we're going to focus explicitly on spatial data because that's largely my specialty. But data scientists extract meaning, inform, and interpret data. And we talked a little bit about it with geostatistics, so we can make facts. So we can say the area cancer rates around Charlotte are higher than the cancer rates around Eastern North Carolina, even though we talk about health disparities in that part of the state being high. We also talked about all the other caveats, things like age grading and spatial bias and modifiable area unit problem. So we also do exploratory analysis, find patterns, build models, algorithms, everything else. And so our particular focus is creation, mining, representation modeling, cataloging of spatial data. This is us right here. There's a lot of tools out there, and then when everyone gets access to the Esri training, and most of us should already have access to it, there's tons of AI and ML and deep learning, lots of tools out there that I haven't even taken the time or energy to explore yet. So what we're going to do in this class is the conversion of information to data to decisions. We want to facilitate. You work for Google or Amazon or some of these other places where you're making six figures. You want to facilitate decisions. That's all we want to do. You're going to be the one that's turning the information, analysts or even text, turn that information to facilitate decision. And what we're going to talk about today is the modeling, which is the diagramming and methods that can be performed on spatial data and automated. So what we're going to do next is we're just going to convert all that stuff to Python code. So we don't even have to write the Python code ourselves. We'll kind of just put in what we can. So we'll learn a little bit about that. Programming, which is the creation of code that can be performed on spatial data and automated over and over again. I want to write a program that does the Pythagorean theorem, a squared plus b squared equals c squared or whatever. And so I want to program what's going to be the input, what's going to be the output. Most of this stuff's pretty simple. And so when we do this within the confines of ArcGIS Pro, our just input and output gets a little bit more complex. Instead of me giving you an A and a B and you calculating C, the input's going to be a feature class. Okay, and what do you want to do with that feature class? Or a database or an attribute field or whatever we're looking at. Data wrangling, which kind of gets into my specialty, is creation of spatial data from large disparate data sources stored in cloud-based databases. Even though I love my computer right here, but if I get in an accident at home, this thing is gone and years of work is all gone. And then data cleaning, we'll talk about for a week, and then we'll kind of integrate with data cleaning and metadata, some of the things that I've done with Python, where that I extract metadata from using Python instead of me going through a little application and clicking on it and copying it and pasting it. I can extract it programmatically, and that's kind of where I get into. We've written a couple of tools that do that, and so hopefully I'll have an opportunity to post some of the papers we've done on that. Also, in this class, what I want to talk about is problem-solving skills, presentation skills, writing skills, job prep skills, interpersonal skills, cover lettering, kind of figure out what type of professional do you want to be. Because the hardest job that you're going to get is your first job. And that first job is gonna be to direct trajectory for all of the other jobs that you're gonna get. And so it's really important that you kind of get a good hopping off point, and I really want to focus a good part of the last part of every class on some of these things that you're going to see, some of the things you're going to deal with, cover letters, all those other things where hopefully we're going to talk to Tyshawn. He's one of our students. He had an interview with Esri recently, which it was people who make our software. And Corey, he works downtown and made that poster, like, what are the things that got you from here out of there, out of it. And so those are some of the things. And I've got some cover letters posted everywhere because, I kind of think of kind of a dartboard here with your skill sets here. And like I was saying in my previous talk there, in about 2006, 2000, I thought I was the greatest GIS person in the whole world. We had this desktop application called ArcMap and ArcCatalog and this little language called ArcObjects, which was based on Visual Basic. I thought I was the smartest person in the world. And I'm not now, for sure. We got cloud. We got all these phone apps right here. We have increased geostatistics. We got tons of different things out there. And so when you go out there in your field there, kind of figure out where you are. Like to me, right near the bullseye, like I'm good with data standards. What data are out there? How are we going to make it? How are we going to turn it into GIS data? What are we going to do to it? Another thing that I'm really not as good at is geocoding. What's geocoding? Has anyone heard that term before? Who was it? Chima. Yeah, go ahead.
Geocoding is trying to get longitude and longitude data and then trying to put that in the map to map.
Yeah. You type in an address and it shows up on a map. Have you ever done that before? Type in an address and it show up on the map? I do this every day. Now, anyone ever do it, 3,000 at a time? That's geocoding. And so we've got some really simple, I'm okay at that, but some other things here, we've got things like GPS, a little thing in your pocket. I bought a $3,000 GPS sitting over in my office right there. I think, did Tony were you the one who told me to buy that thing? Yes. That GPS, have you used it yet? Or? Oh, all right. It's not a Garmin. Tony, what brand is it? No, I can't remember either.
Trimble is I feel like they're the most expensive.
Yeah, it's real. It's like 1 meter. It's like 1 meter. I got the little app for it, but it's a real nice GPS, and we bought it because we were doing that AIML stuff and collecting imagery, collecting data with our phone just wasn't working. So we've got a really good one over there. I would be definitely, this is far away from my bullseye. So anyone wants to be an expert at GPS, go ahead, use that thing, figure out how we can use it. Other things I'm really good at, data creation. How do you create data? Networking. When you type in an address and you want to go there, that's called networking. Has anyone ever done that before? We do this every single day, and so this thing that we carry around in our pocket has a lot of GIS capabilities, but it has some rudimentary GIS capabilities as well. Things I'm not as good at, things like parcel editing. We have a student named Zuri. He was a history major, came over here to our department. That's all he does for a living is editing parcels. You go to like the Durham website, and I live over in Greensboro, so I go to the Guilford County GIS website, and you can see the little parcel, all the information about my parcel, I don't think it has my content, but my deed and all that other stuff sitting right there. And when someone buys or changes it or changes the parcel outline, then that gets changed. And that's all they do for a living is change. Now, who would want to do that? He does. Me, I like doing kind of jack of all trades sort of thing. But he's the expert in parcel editing. I'm not. Things like geostatistics, I'm pretty good at. Geoprocessing. What are we going to do to spatial data to make some sense of it? We have things called erases and updates and overlays and all, buffering. That's kind of where I live. And then things like drones. I can pretend I know what I'm talking about with drones enough. Like things like indoor GIS. Okay, wow. We got business analysts, so we can facilitate business decisions. You know, when I go and build a new McDonald's, where am I building the new McDonald's? Not right next to another. So far enough away from another. But like I was saying, I live over in Greensboro, and south of Guilford College, there's a McDonald's, and then just north of Guilford College, there's a McDonald's. I thought it was kind of neat. They're probably only about a mile apart. Why? Because someone working with business analysis or BIM, business intelligence mapping, has figured out there's enough people in that area to support two McDonald's, and they've been going on. One's right across the street from my daughter's elementary school. You know, she's a lot older now, but right across the street from there. Other things like AIML, I'm not very good. I probably refer this to someone else, or GIS programming. Some of the things we'll talk about here, I'm not good at but I'll show you my skills here with GIS. And then things like maritime tools or cloud GIS, I'm learning about. Metadata, I'm good at. Utility tools like parcel editors or networks or things like that, I'm not so good at. So what I'm hoping to do for this class, like you figure out, you really get a holistic and complete understanding of like, where are you? What are you good at? What are we going to go to Mulready for? Where am I going to say, I don't know anything about this, or say I can pretend to know what to talk about, or send you to someone else. And I really want you to all to think about what's going to be your skill set. What are you going to be good at when it comes to not only GIS, but the geospatial data science? Are you going to be a really good programmer? Are you going to turn this basic stuff into some neat maps? And so think about where you want to do, where you want to go, because if you're pointing and clicking, guess what you're going to be doing? You're going to be pointing and clicking your whole life. You're probably not going to be making the 6 feet. You're not going to be the manager. You're not going to So figure out how we evolve from a pointer and clicker to an automator. How do we automate processes? How do we work smarter instead of harder? How do we write a workflow to automate what we want to do? Because what we're going to do here in a little bit is we're going to open up ArcGIS Pro, and we're going to look at some extraction and some density stuff and figure out which schools have the highest deer vehicle density and all this other stuff. And you can do it using pointing and clicking, or you could write a workflow that does this. So when we input new data layers, it'll change and do some other stuff here. So without any further ado here, I want to see if everyone can log into their computer or a computer. This is where it's going to really get ugly really quickly. Because I already got module 1 up here, and then I want to make sure everyone can log in. Because if not, I have a double secret probation password that we can just all log in using and go from there. Does anyone know what double secret probation's from or not? It's from a movie called Animal House. Anyone ever hear Animal House? Okay, you heard of it. It's good. All right, didn't log in?
This one.
Did anyone get the email about typing in spring with your birthday? You didn't get that one? Okay.
My login doesn't work twice.
Maybe it was only for Pat. Okay, so watch this. We got a username and password. Let me bring it the same one you got. Are you in
The client.
Yeah.
The Slack client,
Yeah.
That's what I use, and then I just,
Okay. So username is gonna be /client. The password is G1 $122 7 $. I want to make sure everyone can log in here. Okay.
Yeah, but it'll change something else. Let's do this.
No, that's fine, yeah. It's weird to have all this on. Did it work? Yeah. this thing's not, is this thing unplugged?
It's plugged in, it's just not, the keyboard's not working, I don't know what's.
And then make sure you're able to log into the POL.
Oh, yours working?
Yeah. And those of you joining us online, I want to make sure you're able to log into Canvas. And I want us to be able to look just right at this. What other classes are you taking, Dolores?
Have I taken or?
No, have you taken here?
Oh, this is.
On here. Does everyone have the GIS software should be installed, okay. Alright. Cause I've logged everyone else in, I wanna make sure everyone can access the GIS software as well. And I know anyone who took geostats last semester, you're able to log in, cause if not, you shouldn't have.
Weird, the client's login's not open on this one.
Oh, wait a second.
This one?
Who am I gonna blame? Yours has Pro, right? Yeah.
It's G1. 1, 2, 3, 7. Yeah, that was nice. This- Protocol set in place to get your account created.
Big Ben, to get your login working, you gotta go to the library. You know, it's a library. For, if you wanna like, your domain, you log in for this? They'll do something at the library regarding the password. It's weird.
This one has not GIS.
Were you able to get it set up? I haven't, I'm going tomorrow. Okay, we'll see.
Okay. Alright, everyone's on. Oh, you're on the computer though, right? Alright, yeah.
Yeah, I'm on the computer. I'm logging in and I think I'll download it.
Alright. We're gonna log in a different way here. Okay. So one of the things we've got here is under week 1, I've got an exercise and I've got all week 1 materials, which is a whole bunch of stuff I've just put into one file. Is anyone familiar with zip file? Zip file, I just compress them all, okay, because I don't want to put them all together. Okay, so all week one materials, this is a zip file. And then we're gonna download this thing, download. Okay, so I'm gonna click download. And I've posted a tutorial on how to do this as well. And so when we look at the downloads here, and I'm also recording this. So when we look at the downloads, under week one, you can see it's a compressed file. It's got about 8 megs. And so that's what it is. And if I were to double click on it, you would see everything that's in there. Look at all this stuff. Who wants to work with that? Not me. Okay. Definitely not me. Okay. And then you can see the PowerPoint presentation I just gave. I've got the exercise that you can submit. I've got an in-class exercise that I have right here. So I got an exercise 1. I also have an in-class exercise. The one thing that you notice about this, it says extract all. So if I were to double click on these things here, they will not open because it's still in the middle of the file here. So we're going to click extract all, and it says select a destination. Where do you want to save your stuff? What do you say, Mac?
In my best opinion is to create a specific folder for this class and then maybe like a subclass for week one.
Yes, very good. These are people joining. I'm just pointing you to. Okay. So Mac made a really good point. Basically, he said create a folder for this class and create a subfolder. Data management is really important, especially when we work with big data. So like file 1, file 2, file 3. I think I'm smart enough to remember it. I'm not going to remember it after, when I turn it off. I'm just not. I'm not that smart. Okay. So where do you save it? Save it wherever you want to save it, but make sure you can find it. So we can click on browse. And I'm just going to go to my class right here. And I created a folder already for this class. I call it EASC 5130 Data Science Spring. And I'm just going to save it under working, okay, because it's already in. So I'm going to click extract. Now everything's going to be sitting right there, okay? Everything's going to be sitting right there. Now I've got a couple of exercises. I've got an exercise 1 and an in-class exercise week 1. What do you think we want to do? Let's do the in-class one first. Okay, what's up? We got software here. Let's go here. Okay, let's go to modules. Okay, down over here. And for now, and down over here. What's that?
I have one of those that you break,
Yeah.
getting diagnosed.
Okay, good.
Yeah.
Yeah, I'd save everything to a flash drive here.
Where'd you go? Come on.
Okay. All right, so let's click on the in-class exercise 1. In-class exercise 1. I've just got a couple of little directions what we're going to do. We're going to just do a short little exercise since we're here till, we're still here till 8:30, so we've got a while.
7:30. 7:30, 8:30. What they must offer us with anything?
No. Because I wanna make sure people are able to log in as well. And so we've got Dolores, we've got Andy, we got Eric over here, I wanna make sure no, let's extract, let me show you. So we're just gonna save it here under download. Here, section 5. Let's check out the in-class exercise 1. Alright, so to log in. I need to get
Still didn't do it?
I didn't. It's still sign.
Is it the same?
Well, I need.
Nearly.
Where's?
Just cancel. Yeah, no. Thanks.
Okay. Okay, Dolores, let me just send you this. All right, D Soto 2 at Eagles. Does that look right?
That's right.
It's been a minute.
Right, and I'm kind of managing it from here, but I can see everyone who's logging in here, so this is pretty cool.
Dear coalition.
Let me check.
It's just exercise one.
I think we're gonna do the in-class exercise 1.
Mhm.
Or
Got it? Good.
Right.
It's the same template. I think this is the main food. And it's what you see.
Okay,
This was the-
this one.
All right, so we got this open. First thing that we're looking at here is we're looking at deer vehicle collisions. Now, we got a red exclamation point next to public schools. What's that mean? Someone, I'm gonna point fingers for it. Someone left us their file. What is someone playing here? Check out the. No, it's just kidding. But one of the things, all kidding aside, this looks like, I did mess up the data management part of it. Part of it was, if you click on week 1 right here, you see there's colleges and universities. Basically, that's what I want to do with the public schools right here. And for some reason, I don't know why, but I think I wanted to show you what a shapefile was and it didn't connect it to the map. So you see it sitting right there. Now, some of the things that we can do up at the top here. Now, most of you are looking at ArcGIS Pro for the first time or being introduced to it. Maybe Andy, have you seen this before?
Yeah.
Oh, you're familiar with it. Everyone else, a couple of you, it's been a couple of months since we looked at it. But what we look at here, and those of you joining us online here, when we open up the software, and the software is downloadable on the link that I provide. So you download it, you sign in using your NCCU username and password. So everyone sitting in this room has logged into the software. And what we're looking at right here is, in the left here, we got a table of contents. Okay, you can see we have deer collisions. So if you zoom in or zoom out, this is a map of all deer vehicle collisions throughout the entire state of North Carolina. That's a lot. What does this look like to you? Just a big bunch of dots. Kind of like we look at with crime or whatever here. We need to start to make some sense out of it. And what I wanted to do for this exercise was basically just do a little bit of density mapping so we could see if there was a relationship or look at schools that had the highest amount of deer vehicle collisions around those particular schools. If I right mouse click on deer vehicle collisions, I can open up the attribute table so we can see there's about 21,000 down in the bottom left here of these deer vehicle collisions. And it's got what all the attributes used to store these deer vehicle collisions. So we got all the attributes used to store them right here. Okay, most of these, I don't know where I got this state. I think I got this from like North Carolina someone over at UNC Chapel Hill. But basically most of these are crash IDs, number of this, number of county or whatever. But this is truly what spatial data looks like. Now, if you move your mouse around here, we got these numbers going on. What do these numbers represent here? Coordinates. Are these latitudes and longitudes? No, why not? How do you know they're not?
Just by like the.
Just by the measure. You know, they're really too high. And so these look like northings and eastings. And so basically when we create coordinate systems or we create state plane coordinate systems, we flatten the state of North Carolina, flatten the earth. So that we have a 0, 0 point down in Alabama, and so that everything's in our first quadrant. Because when we start dealing with latitudes and longitudes, we've got sine, cosine, tangent, all that nasty stuff that you wanted to leave when you took trig and all that other stuff here. And so they've done the job of flattening the earth out because we know in reality North Carolina has topography and it's also on a 3D, what we call an oblate spheroid. That can be applied mathematical formulas or whatever. So the good thing about this is that we want to look at these coordinates here. So we can move in, we can move out, we can look at spatial relationships with these. And so most of us, I think almost everyone in this class has kind of taken this and is familiar with this. Now, the one thing that I did mess up here is these public schools here. And I somehow want to connect these public schools with these colleges and universities so I can start working on kind of exercise 1. And I've got climate data. And that's what we'll talk about in exercise 1 a little bit, because I want to kind of look at this and then I kind of want to start working on exercise 1 and give everyone a nice taking off point. Because like I said before, it won't be due next week. But those of you who've taken GIS before or taken geostats, I'll expect you to kind of hit the ground running with that. Now, up in the top, we can add data. Okay, so if I click on add data, there's a lot of different places we can add it from. So under map, up at the top, and then go to add data. Look at all the different places that we can add data from. Okay, so go to map right here, and then add data. Now, in this day and age here, we can navigate to different places right here, but now under portal is all the data sitting out there in the cloud. So if you click on my content right here, this is all the stuff that I've made here. Okay, owner, team, room, this is all the stuff that I've made. I click on my favorites. I don't have many favorites. My groups, my organization. You've all been added to my organization. So if you say, hey, I want to go and add counties right here, guess what you can do? I can go and add all the counties sitting right here. Okay, exercise 2. Okay, oh, this is block groups right here. But I can type in the word counties. And everything that has the counties comes up right here. NC County State Plane is a feature layer. I can add counties right here. And so now I've added the outlines of counties right there. I can add zip codes or whatever. Now, this is all stuff that I might have created. That might be junk. Who knows what it is. But this NC Counties is something that I like. And it provides a good background here because someone went and messed up the NC Counties original. Probably just because it's sitting in another database. It's sitting in another database that's not, that I didn't upload or whatever here. So I can zoom in, I can zoom out on all these things right here. And we can start to do some of these queries here. Now, if I right mouse click and click on properties, under source, I can see exactly where this is sitting. But now when I go to North Carolina counties and go to properties, you can see it's got a dedicated URL for it right there. And this is the thing that I never did in 2007. It's like the last 5-6 years. Now we've got these things called services sitting out there that look and feel like feature classes. Now, on the back end of things, I could change the property so that I say, hey, you can't query these, you can't edit these, you can't upload these, but that, for me, that would take too much effort. And so if you really wanted to, you could probably delete the stuff, rename it, and do all these other things, or export them or whatever. But these things are sitting there in the cloud with a nice map ready to go. You also notice right here, you've got underlying maps right here that are sitting there ready to go. And so when you open up this map, I can uncheck that world topographic map. There's something right there. I can go to base map, and instead of having this base map, I can have imagery. So look what I can do. I can just click on imagery up in the upper left. Look what I've added. Just all this maps, these maps right here. So if I'm doing something with land cover or whatever, I can add these. So there's a lot of different places to add data. You know, it's increased exponentially. And so the days of me sitting around storing everything on my flash drive and you know, external hard drive, you're going to have to pry those from my probably cold, dead hands, you know, even though this cloud stuff has so much stuff out there. The trade-off to cloud here is, you know, I zoom in and zoom out, there's a little bit of a lag here. So I zoom in, zoom out. And when we looked at geostats and we talked about this in raster, you know, the size of these files is just absolutely amazing. You know, the amount of, you know, neat computer stuff that we have here is absolutely amazing. And so now I've got my map sitting right here. The one thing I do want to do as part of this kind of this real rudimentary exercise, we're gonna do a little interpolation and then extract feature to point or extract value to point is that we are going to go and add the counties. I'm sorry, we're gonna go and add the public schools right here. So we're gonna go to our black plus sign and we're gonna go back to where we extracted it from. Now we're not sitting on servers. Yeah, we got schools right there. I'm just looking at a couple things here. But we're gonna go back to where we where we extracted everything to. So where did you extract everything? Did you go to downloads? So, so I'm gonna go back to my working, week 1. And then I've got something called colleges and universities sitting right there. So we're just gonna look for colleges and universities. I can change the symbology. I will. Let's go back to where did you extract? Downloads? Now, what our goal here is basically what we want to do here today, and I wrote it down in a Word document here. Now, we're not gonna do that one there, because of the school, but what we can do here, we can run some simple queries. So I wanna find all deer vehicle collisions within a certain distance of each school. Do we all remember that? Okay, good. And so I could do something like select by location. I wanna input features are gonna be my deer vehicle collisions within a distance of colleges and universities, and we'll do something like 10 miles. 10 miles. Is it 8? Yeah. So I just want to make sure we're able to kind of, well, I do colleges and universities. It's called statute miles. Just 10. I just want to make sure we vote on it. Survey mile. So this here. Where'd you unzip? Down. So you can down. Like you wanna look at this. And then see how many goes by.
So.
Oh, it doesn't.
Yeah, I mean, having statistics that shows how they. How likely it is, like, one star.
Yeah.
Google that thing and then download it. You know it. What are we looking at here?
I'm trying to bring back where I was at.
City schools.
Maps right there.
Yeah, but I was supposed to go back to.
Here's my back.
If you have that data.
I had my notes
It's a little bit harder.
and I had the town,
Yep, you added that.
you know. But the
Go to that now. Go to the black plus sign.
did that, yeah.
Let's go down a little bit, because now we got a whole bunch of other stuff that we can pick. So this PC, downloads. Double click on that. Week one. Week one.
So then you can. Depending on the size of the field, making that more relevant. Think what days that's around.
Okay.
Basically, it'd be like normalization to make it.
Now, what we're gonna do here, we're gonna do two real simple things right here. Okay? What we're gonna do, we're gonna find the college or university that has the highest density of deer vehicle collisions around it. Basically, just which one has the highest, which one has the lowest. Now, how do you calculate density? What is density? And this is probably for folks who took this class last semester. Can we create maps? Can we go between vector and raster? How?
How many occurrences happen with so specific.
So we can create a density, because that's what they do with crime maps, right? When you create a crime map, do you look at all the dots? No, we just look at like a red or blue or green or whatever, some sort of, they call them heat or density map. So the first thing we want to do is create a density map. And then two, and this is taken right from class last semester, we want to figure out which one of these points, the density right at that exact point, right? Does anyone remember that, what we did there? That was called extract values to points. And we're going to do it by hand first, and then we're going to create a little process that goes through and just does it over and over again, and we're going to look at the Python for that. And then we're just going to extract values to points. In this case, it's colleges. Okay. So we're going to do two really simple things. We're going to create a density map. Okay. And so now we're going to go over to analysis and tools. Analysis and tools. And those of you taking geostats, you're like, okay, I remember this. I remember this. And we can clear our points too, so we don't kind of leave anything. So up in the top here under map, we can clear our points. So there's nothing blue or highlighted or anything like that. And we're going to go to toolboxes. And we're going to go on to spatial analysis and click on something called density. So instead of looking at all these dots, we're going to make a density map. And I'm just going to click on point density. What do you want to map a density of? You do vehicle collisions. What's the name of the output raster? It's going to be that thing. Do we want to just leave everything else the same? Sure, why not? We can change those. We can change our search radius. basically, does anyone remember when we created a density map, what did we do? We went to this cell right here, we calculated the density within that circle, and then we went to the next one, and we just created density with that circle. So how big is our raster size? 3,938, I assume that's gonna be feet, so about just under a mile. And then our search radius is gonna be about, I don't know, 6 or 7 miles right there, 5280 times that. We'll just leave everything for now.
That's where I.
Yeah.
I probably don't think so. So. It's a spatial.
Density is point density.
Yeah.
Oh, okay, we gotta license that tool. Who am I gonna get mad? I'm gonna get mad at Maholtra for that one. Does everyone have access to the tool that I had? All right, SCHULER?
Yes.
Okay. So here I can go to manage add-on licenses. You got access to it now.
Maybe to restart.
Yeah, just try it now. Yeah.
Yeah, it's fine.
Yeah, see if that works. Is it working now? Okay. That's it. Didn't do that for you? Might need to turn it back on, and maybe you can register the license. Did you set the environments on that? Did you set the environments on that or no?
What do you mean?
Did you click on environments? Like
No.
that? Okay, all right, cool. All right. And when we're ready, we can just run this thing. Let's see what it looks like. Looks like Benjamin already ran it there. Now I can uncheck this. And now what do we see here? A nice kind of density map here of vehicle collisions. Now, Benjamin had a good question. We could set the environment so that it only looked at the entire state right here, but looks like we kind of set this here. It looks pretty good. Now let's go again. Pretty clear. There, space. Yeah, this is some new stuff. Yeah, you got a good affinity for this already. Do a nice job here. All right, so you made a map like this. Which school has the highest? Does anyone know?
Should be student week.
Somewhere in Wake County. How about we just go and keep clicking on all the counties and figure out which one's the highest? You wanna do that? Yeah. What did we talk about last semester, what we could do? Remember we did that with that error PM stuff? This is in geostats. Maybe you weren't there after. Remember what we did? How do we figure out what the value is of this raster at this point? Is there any way that we can extract? Interpolate, well, interpolation is something different. Interpolation is when we have distinct values. I just want to figure out what the value is here. Now, what we've got here is, let me see if there's a tool here called extract. Extract by points. Ooh, this looks pretty cool. Extracts the cells of a raster based on a set. Oh, not really. Extract. Extract values to points. Okay. So extracts the cell values of a raster based on a set of point features and records the values in the attribute table. Isn't that what we want to do? So it'll say Buncombe Community College 37 or whatever the value is. Wake Tech, wherever these points are, because we got probably, I don't know how many points we've got here. Okay, so extract values to points. All right, let's double click on that. It's got 2 input parameters. What's the input points? Colleges and universities. Input raster is what we went through the trouble of creating. And then I'm going to just type in the word final output. Cool. All right, let's see what we got here. Right mouse click. All right, what do I got? I got 130 points here. What do I have? All the way to the right, what do I have? Raster value. What do you think that is? That's where we combine it. If I were to open up the original feature class, do you see a raster value here? You better not. No, I don't. So now what I have, Alamance Community College. What is the value over there? That's going to be 0.82. 0.82 what? Does it really matter? I don't really care. You know, they're densities, right? So one to the next, to the next, to the next. We don't have to worry about normalization or any of that other stuff, right? Don't. Okay. So how do I figure out which one's the highest and which one's the lowest? Sort by ascending, sort that by descending. So sort descending, what do we got here? Greenville. East Carolina University, followed by Wake Tech, followed by University of Phoenix here, and then Sprint Community and Nash, St. Augustine's, North Carolina State. So now we can sort these. You know, and if we really wanted to, we could change the symbology. Now, am I going to color in these dots or am I going to make graduated symbols? Graduated symbols. So I can make some nice graduated symbols right here. Based on what? Raster values. So look what we got here. And so like Chimo alluded to before, all right, it's looking like Wake County. We could change the symbology on those. You all set here, Aaron? That's the point density. Let's uncheck this stuff. You went through the trouble of reading. Good. Now, basically what I want to do is with the word extract values to points. Right there. Where my input point is how you. Now, let this be two times. There it is. Oh. All right. Erica has a different answer than me. Why? Is she wrong? Not necessarily different data set, but she might have set different parameters. So when she set her search density to be, 50,000 feet instead of 30,000 feet or whatever. So those input parameters are going to be neat. Now, as part of this data science class, what we're going to do is, who wants to go and redo this for a different set of deer? not me. So what we're gonna do here this time is we're gonna create a model, a workflow model to go through and do this. Now, I've got a video on how to do this, but I want us to do this by hand. Now, this is just gonna be two little steps right here. But what we're gonna do is we're gonna drop and drag, and remember what this was. Point density and extract values to points, okay? Because we're gonna have to figure out where these things are. And so now we're gonna go back clear. We're gonna go back to analysis. And in the upper left, we got these things called Python. Has anyone heard the term Python before for programming? This is a really powerful programming language. So this is the scripting language for our software. Scripting basically means it goes and performs the commands. And then on top of it is called Model Builder. And we're gonna click on Model Builder. And what do you see we got here? We got a little, basically it's just a little model right here. Yep, so click on Model Builder. So click on Analysis, and then Model Builder. And then I just drag it, that's fine. Drag it up in the middle there. That's what I like to do, is kind of drag it up in the middle. So we got Model Builder. So now we're gonna drop and drag tasks so that we can automate those. Oh, okay. I guess I already did it. All right, also, look what I did here. This is pretty cool, huh? I kind of already did it, but that's a different model that I've created. Yeah, if you click on model, I've already created another model that we've done. But what we're gonna do here is we're gonna add data and tools and connect them to build a model. So the first thing we're gonna do is, what are we gonna look for under geoprocessing? We're gonna go back to geoprocessing, extract by point. You see that point density that we went to? We're just gonna drop and drag it right here. Look what I just did to the model. So I went and dropped and dragged point density right onto my model. Just drop and drag it right on. So we got big fancy people getting descriptions, all that stuff. Yeah, that's good. Now we want to create a new model here. New model. Let's not mess with this one. That's an old one that I created. Excellent. Okay. Now, why does it look so gray? Well, I got to put stuff in there. And I got the little arrows. What do you think the arrows mean? That's the direction it's going to be going. So I got point density, which is going to be my input. Why are these things different shapes? Why are they different shapes? Exactly. One's the tool, one's the input parameter. Remember, what's an input parameter? You're going to hear this word a lot. The thing that it needs to run. Remember back in the day you did f of x equals 2x plus 3, all that stuff back in math class? Well, what's the little x going to be? What's the input parameter? And so what we're going to do here is we're going to double click point density. What's the input point features? Okay. Deer vehicle collisions. Does this ring a bell? Okay, can we change these? Can we change our radius, change our neighborhood? We can do whatever we wanted to. Hey. Okay. Now what we're gonna drop and drag this over here. Go back. Nope, nope. I'll drag this thing over. There we go. Now double click on point density. Now, once you get everything, we turn it into colors. What do the colors mean? Okay, this thing's ready to roll, meaning we got an input parameter. We're gonna run a point density. What's that green gonna represent? The output. Okay, the output. You can set whatever you want, anything's fine. I just changed mine, just so I might get a slightly different answer than what I had before. Okay, so I get a slightly different answer than what I had. And in addition, there are also commands like select by location, all those, so we can do some select by locations and drop and drag those things in there. The model that I have there with a different data set actually has a set of those where I extract and do all this other stuff for true data preparation or, data prep. Now, what do we use that deer point to? We go through the trouble of creating this thing called point deer to, or we can create it, we can call it something we really want. But what do we want to do with that? We want to take that density map and extract values to points, right? We went through the whole trouble of doing this. So I want to extract values to points and drag this here. So extract values to points.
The multi-values?
No, type in, I'd go up into the top and just go up to the top and type extract value to point. Very good. Now you can just drop and drag that thing over there. Drop and drag that thing over there. Move it over there. Now, the other thing about this now, extract values to points. How many input parameters is it gonna have? Let's double click on this thing. What's it need? What's the input point features? All right, colleges and universities. What's the input raster? This whole, which one am I gonna pick? The DR1 or the DR2? DR2, why? Because, well, I went through the trouble of creating it with different set of input parameters.
You said D2?
No. These are two input parameters. So now for point density has one input parameter and one output. Extract values to points has two input parameters because we're based on a raster, and then I call it extract college one. In a perfect world, you could be given nice, pretty names that you're gonna recognize, but I'm not that person. Right now. But when we have some final output and all this other stuff, because now when we go on this model and zoom in and zoom out, some neat things we can do is we can export this thing that we can plop right into a research paper. Double click there.
See the two, with the point?
Well, you have the DR1 right there.
Yeah, but where?
What about college and university? Now click OK. Because, all right. Let me try something.
You said it was a two?
This one, I'm going. So we're using this one.
Oh, you're done.
See what we're doing here? So we created the density map. This is the density map. We're using the density map and the point to run this thing, which is gonna be. Now, when we go to Model Builder, look at what we have up at the top. We've got run, variables. We can insert tools, iterators, logicals, if then else. Lots of things that I really haven't done too much that I actually personally program in Python instead of using these. So you got a whole set of tools that we can work with right here. Now, what do you think we're gonna do if we run it? If I click run or validate, I can click validate. It looks like it likes me. But I'm gonna look for something called extract college one. But when I click run, watch what it's gonna do. Look at this. I got some stuff that's red, and then it's done. All right, where'd it go? We're just sitting here. Where's my map? I went through the trouble of making this. Where is it? I can go to my black plus sign here. And there's a way that we can add them, but that's it. Where is that? There we go. Add to display. Good. Add to display, and there we are. So you've done this before, Dolores, right? Okay, good. All right, good. I was getting real frustrated real quickly. So, like I said, I want you all to be better than me at this at some point in time. Okay. So you could right mouse click, add to display. We can rename it, everything else. But now we've got this brand new interpolated surface. We can run the raster values. We can see the feature class attached to it. So we got this raster value, sort descending. You can see this time when I ran it, my highest density was Shaw University and then St. Augustine, and then ECU was way down on the list. Just when I changed the input parameters here. Ugh. That's just object ID, raster values. Okay, cool. This is the stuff that I like doing right here. Now, the thing about this is that this is a nice picture here. When you click on these ribbons, and the thing about this ArcGIS Pro is that when I click on model specific options are up at the top for me. So variables, iterators, select all these other things. I can click on export. Two things I can do. I can export to a graphic, or I can export to a Python file. And Python is going to be the scripting language for ArcGIS Pro. This is going to be the commands. And what I want us to do is export to each and then see if we can open it up and see what they look like. So when I export to graphic, I'll just go here to wherever I want it here. I'm going to go to my working. I'm going to call this Tim's graphic. There it is. Uh-oh, we might have to open it up again. Here's my graphic. Oh, cool. What can you do with this thing? Insert it into a paper, do whatever you want. Okay, was everyone able to export the graphic? You able to do it, Lauren? Okay. Just the graphic. It's just me personally. You know what I would do? I would just screenshot the thing and paste it over, to be honest with you. Now, the other thing, which is a little more important, is that we can go export to Python file. Now, I'm just going to save it in the same place right here. I'm going to go save it in the same place, and the subscript or the extension is going to be .py. So we're just going to go to our same folder, save it as a .py folder, and we're going to open it up and see what it looks like. I'm going to working, and we're going to call this Tim's model. And then here we are, Tim's model. We can open it up. Uh-oh, I don't wanna do that. Oh, I did that. Cool. And when you double click, look what I did right here. Look at this cool code I just wrote. And so when you export it, let's open up that Python file, double click on it. There it is. Now, what you're looking at there is what we call an editor. And so depending upon the type of editor that you have, you could open it up in Notebook if you needed to. But look what we have here. Generated by Model Builder on 1/22/2024 at 6:54. Now I want to make sure everyone's able to get it.
So you go with this one.
This is a good group. I don't really move that. Or just try it right now, it's clicking. Try it. Like, we're not gonna get into like debugging, we're gonna, and this is gonna be pretty, we're only 2 weeks.
Okay.
Alright, right mouse click, open with idle. And then integrated developer. Yeah.
I know, I have the same things.
Open up subjects and see what that is. What I have here is something called Visual Code Studio. So that's like my default data editor, but yours should be some sort of like Python default IDLE, which is integrated development learning environment or something like that. And so you can see your Python code right there. But when we open it up, look what we have. This is your first Python program you wrote. You see kind of what it does. Colleges and universities equals colleges and universities, deer vehicle collision. What do we do right here? This is the database, point density. Look what I did. I just ran a little command right here and then I extracted it and look what all this cool stuff that I did. So none of us ever gonna write any of this stuff right here. Now, eventually what we're gonna do is, instead of you saying deer vehicle collision, you could say, hey, let me have an input parameter of which one is gonna be this, which one's gonna be that. I wanna put this into a loop so that we can do this, because what we're gonna do now is open up exercise 1. You kind of do very much the same thing, but it's gonna be for adding XY data. Remember adding XY data? I see a couple people nodding their head. And then we're gonna do the same exact thing with extrapolate values. So instead of creating a density surface, we're gonna extrapolate values. And so I heard someone say the word Kriging and splining and all that other good stuff. That's what we're gonna do here. So what we'll do here real quick is let's open up exercise 1. Let's get started on it. And we're gonna do it together. And then I'll let everyone finish it up. So under week 1, I've got exercise 1. So exercise 1, and I can't stress this enough, I don't want people getting overwhelmed. I don't want people getting too overwhelmed. So it will not be due next week because we had a couple people learning some things here. So what we've got here, take the Esri tutorial titled Building Geoprocessing Models Using ArcGIS Pro. And so we've got a tutorials. We've got the Esri tutorials. Does everyone know how to access the Esri tutorials? Okay. Sign in using your username and password. Make sure you just take the little Esri tutorial and you're going to submit that thing using, you're going to submit that assignment through the assignments. Okay. And so I've set up the assignment so you can submit Word documents, anything else. So you're going to go and take the little class, make sure it says Benjamin Williams or whoever else on it instead of like EIS student 1. I know some students use like Adobe Acrobat to go and like change the names on it and the same. it's cool, I don't like it, but I'm not gonna stay at night, stay at night, making sure it's an original right there. So under the training, go to training.esri.com. Training.esri.com. Sign in using your credentials that we just talked about. We go to catalog. And then we can just type in what we're looking for under exercise 1. And this is something that we can do on our own time. And building geoprocessing model. You can see that I started taking it myself. So I really like it. So what you're gonna do, you're just gonna go, take the class, follow it. This thing says 2.5 hours. I could probably do it in an hour. Me personally, what I like to do is I like to go and do the hands-on exercises. So you click on it and you go through, and I think it gives you a little quiz at the end. Take the little quiz, give the little certificate, show me you took the certificate, and I'm happy. Now, the next thing that we're gonna do is just simulate basically what we just did. So we're gonna open up exercise number 1. And what do we see here? We see a whole bunch of files right here. And I'm gonna be kind of interested to see if there's ways that we can automate this really easy using Python. Not today, some other time here. But here we're gonna create a model where that we open these things up. Okay, all right. So let's start working on this thing. What do we want to do? I want to create a model builder that does the following. Exports the standalone table to a table that's stored within the exercise 1 database. Okay. Now, what are you looking at right here? If I right mouse click and open, does this look familiar to anyone? Anyone remember these things right here? Where did I get this stuff here? This is a text file, and this is taken from the Climate Prediction Center. So I've got a latitude, a longitude, and the temperature, and this is the maximum temperature on that day. So on November the 11th, 2023, when I wrote this exercise, I guess, the maximum temperature was 50, 43, 37, or whatever. And so what I want to do is I want to export this thing to a table. All right. How do you export something to a table? Just right mouse click, export, right? That's cool. Because right now it's a text file. Where's that text file live? Wherever it wants. Do I want to store it in the database? Sure. And if you really wanted to look hard here, we'd right mouse click and look at the properties, and we'd see that this thing's sitting somewhere in week 1 climate data. So look what I got right here. Who wants to go through and do all of these? You think you can write a loop that just goes through and does these? We'll worry about that later. Okay, so you can see the max temperature for the 7th, for the 6th, for the 5th, for the 4th, for the 3rd, all the way from the 25th, all the way up to the 7th. You get an idea of what we're trying to do? We're trying to create a surface to figure out where the max and the min temperature is going to be at colleges and universities throughout this area based on these values. Okay. Now, most of us, we've all kind of touched and hit on these. Okay, so I can right mouse click and I can go to data, export table. Now, where am I going to export it to? Right there, Air Max 2023 2011 0. I better put a 7 on that. Why is that 7 going to be important?
So you know what it is.
Know which one it is, know what the date is. And all I'm doing is, where am I saving it? I'm saving it in my file geodatabase. That's the important thing. I'm saving it in my file geodatabase. So I'm taking it from what we call a flat file or a text file that I stored off the internet, downloaded off the internet from the Climate Prediction Center, and I'm putting it into the database. Why would you want to do that? It's all in one place, I guess. That's what I do. You know, I'm old, I'm still used to working with data all in one place. There it is. All right, check. First thing's done. Next. Display the XY data as a feature class, showing all the stations. Okay. Right mouse click. How do we display the XY data? No, Lauren's good at this, right? You remember this? Okay, that's okay. Why did you get in there?
Seven on there.
Yeah, it's okay.
Maybe it's not the data. But that's like the rate of the same.
Yeah, it looks like you were kind of, it was looking for a value, it couldn't save it. Is that what you had down there? What's that? Make sure you're saving it in a place that really exists. I think with a couple of you there, you were saving it like on the C drive or something, and the computer's like, hey, there's no C drive, there's no C, it's sitting in my downloads or my documents or whatever. So remember, these computers are stupid. They're gonna do whatever you tell them to. Okay. Exercise one. Click on that exercise one. Now add 7. Let's put an exercise 1. Click on that one, and then add 7. Yeah. Now, I think it was just absolute, I don't know what, I could make something up, right? It makes me sound smooth, but. Sounds smooth.
French people been military, I don't know, some.
What's that?
Which French?
I just worked for the Army. I never was in, my wife was in the Navy. Oh. Okay. So we did this. Okay. Display the XY data. Okay, so right mouse click, display XY data. Okay, now I want to show these as latitudes and longitudes. Now, what's going to be the coordinate system? That one. WGS 84. What's WGS stand for? World Geodetic Survey? Something like that. The World Geographic Global Coordinate System, World Geodetic Survey. Okay? Yeah, a bunch of people. Yes.
What's the next one?
Right mouse click, display XY data. So that 3, 2? Yep. No.
I mean, I think that,
Yeah. This is the new version. All right, but we don't want that.
Okay. Yeah, things to say. Took these tables. Using the wrong. That's telling you the temperature. That's where I like. So, yeah. So this now still.
Now we got about 15 minutes, so I'll kind of put a nice bow on this and hopefully give you all a charge for homework. Like I said, it's not going to be due next week, but I want to give you some time to kind of think about the process, because what do you think I'm trying to do here? What do you think we're going to be doing, just like we did in this exercise here, is that we're going to figure out what the highest and lowest temperature is. And not only that, we're going to cut and paste it into a nice, pretty Excel spreadsheet so we can get a list of all of the temperatures for all of the colleges and universities sitting there ready to go so we can analyze and we can run some neat statistics on. And so, like, kind of looking big picture, exercise final output, what do you think you're going to be able to do at some point in time? You're going to be able to do using Model Builder. Look what I have here. We got a list of all 130 for the first, second, third, fourth, fifth, sixth, seventh. You're going to be able to cut and paste these. Who wants to type all of these at once or type all these separately? Not me. And for now, we might be able to run these models that just do this, and then we can cut and paste everything in here, 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 here. Let's keep working a little bit more to kind of make a little more sense of this here. All right, next thing that we can do in this model, because eventually what you're going to do, instead of hand jamming all these things, you know what you're going to do? You're going to create a model so it just runs it. And so you can do it for November the 7th, November the 6th, November the 5th, November the 4th, November the 3rd, November the 2nd. And just run the model over and over instead of working with November the 6th text file, you work with November the 5th text file, and then November the 4th text file. So you can rerun this thing over and over again just by changing one little value and get this different results every single time. So those are some of the kind of big picture things that we're thinking about. So as we go through these, what else do I want to do? Extract out only those values within 50 miles of, okay. Does the 50 miles really matter? No, why not?
It's a big radius.
It's a big radius. Also, it doesn't, but you know. So we extract out those, but what's the big thing we're gonna do here? We're going to do 4 and 5 where that we run the IDW interpolation routine. Now, what's the difference between interpolation and density? Both of them, you're creating densities, so you're creating raster surfaces.
Interpolation is predictive analysis.
Exactly. Who said that? Caitlin?
Yeah.
Very good. Interpolation is predictive analysis, meaning that, and if I really wanted to, watch this. I'm going to right mouse click. I'm going to go to data labels. And I'm going to go to label properties. Come on. Just, here we go. Okay. And so we see these values right here. This is the temperature on these particular days right here. Okay. This is 74, this is 76. What's the value right here? 75. Why? How did you know? It's halfway in between. Okay. So when we create predictive surfaces, we use, in this case, I use something called IDW. What's this word IDW mean? Inverse distance weighting. Basically, what do you think the value right next to this is going to be? Pretty close to 74. Why? Because it's closer to 74. So it's inverse distance weighting, meaning that weight is going to be inversely weighted. Now, people use words like Kriging and splining, and those are just different surfaces, different methods to create these surfaces here. So I can figure out what the cells are here. So what you're going to do is you're going to create basically a raster map that you just did, but an interpolated surface here using IDW. And then instead of density map, we're just going to IDW map and then extract values to colleges. And then you can just cut and paste those things straight into Excel. And if I think of it, I'll probably do a little video on this tomorrow here, but we can create an IDW surface to do that. The reason why I only extracted out for within 50 miles, does anyone, I think I figured out, only 50 miles within North Carolina, because if you do it for the entire United States, run an IDW, it's gonna take a real long time to run. And so I only had you pick out everything within 50 miles so that you don't want to run it. Because what we're going to do is we're going to figure out which college and university has the warmest and coldest day for each of those dates. And this gets real specific. Really, this is probably running something like this or creating a model to do this is probably a really good, thesis or internship topic. Hey, let's create a little model. Let's build on this so that we can build in climate data, because eventually you get an idea like it's 101, 1102, 1103, 1104, 11. You have to hand type those in. We can stick these and automate these processes as well using some of these iterators that we'll start talking about next week with some really simple basic programs. And so we'll extract those out. And then the last thing we'll do here is we'll create an interpolated surface, because eventually what we're going to do, we're just going to drop and drag these things into Model Builder. Okay, real simple. Drop and drag these things right into Model Builder that we just did. Because I didn't create the model already. Okay, because if you look at that previous model here that I created for the in-class exercise 1, so if we kind of look at this model builder, you can see some of the previous models that I had created before or something. Select layer by location. What's select layer by location? Select all stations within 50 miles of counties. Okay. And so we got deer vehicle collisions. We got something called export features. What do you think export features is going to be? Brand new feature class that we can export out. So we can use something like this here. Okay. And so I did a select features here. Look what I did right here. Deer vehicle collisions within a distance of 1,000 survey feet. I was doing something else. So I can do select layer by location. It creates deer collisions or whatever I'm looking at and export those out. Can you do those? I bet you can. We just did select by location, right? Give me everything within 10 miles. Now we're just creating the model builder equivalent of it and exporting it out. Why do I want to export it out? Is there any special reason why I'd want to export it out? What do you say, Matt?
The model itself.
Yeah, why did I export it out in the model itself? Why did I go through this extra step of exporting features instead of just using that deer collision to do my next thing?
I mean, you could use it and apply it to different things later on.
Exactly. I was probably that was my thinking. No, it was probably to save it. So if I need to go back and screw something up, I've got something like stations 1102, whatever, 2023 1102 sitting there. So in case I did mess something up, I can go back and have that feature class sitting there for me to reference instead of me using this kind of temporary output that is just part of the model that will kind of disappear back into RAM or ROM or wherever it is. Do we feel confident about finishing this or working on this? Yes? No? Good? I know everyone here did IBW. I know you did, Barbara. You remember. Okay. You know, Mike did. That's you remember IBW, right? Yes. Inverse distance weight. Yes. So the IBW and Erica will kind of play a little catch up with some of this as well. Randy, I think you got a good idea. It's just a matter of finding it and stuff. And Lauren and Matt will play a little catch up too. And we'll just figure out where to have and find it. Because now instead of having 2 steps, we're probably going to have about 5 or 6 steps. And then from there, we can just cut and paste it right into Excel. So if I think of it, you all know I like to record videos and put them on the internet of me kind of simulating it, but not doing the exact same thing. And so what I'll do is, especially when we loosely couple some of these applications, when we go between ArcGIS Pro and Excel, when we need to export or copy or whatever, I think I'd have no problem being able to do that and move those over and kind of talk about some of those tricks here, because we're working with 130 temperature, 130. Think about building that really neat Excel spreadsheet that now we can start doing our means, median, mode, maxes, standard deviations, all that stuff we talked about last semester. Instead of Mulrooney giving it to you, you generate it yourself and automate this fairly easy. All right, I'm done talking because we didn't take a break today, so I apologize for that. All right. And those of you online, if you got any questions, especially about getting the software going, let me know. We'll set up some WebEx and we can install the software and get that going. Most of you joining us online, Caitlin, Sarah, I think Alexis, and a couple of you others should have a good idea as to where and how and that to download the data and get a good start on. But a couple of you are not familiar with the class, we'll get this going and we'll definitely hit the ground running. But this is not due next week. We'll kind of ease this in with those of you who are not familiar with GIS. So we'll see you all later. Be on the lookout. What's up?
Can I ask you a question really quick? So with
Yeah.
exercise 1, the steps that you have us following, do you have us following that steps because of model builder? Because in my mind, I would have went ahead and extracted the North Carolina
5 people.
temperatures before I did before I did the XY data.
Yeah, feel more than free to, because that's just running an attribute query. Yeah,
Okay.
you run the attribute query, I'll run the spatial query.
Okay, so it doesn't matter how I do
No.
it as okay.
No, and
I just
only
wanted to
the
make
North
sure it
Carolina.
wouldn't affect
But
it.
remember, I wanted 50 miles of North Carolina.
Okay.
Yeah, so that is a spatial query, because if you're treating North Carolina as an island, then you're gonna run into some issues at your edge effects where that you have places in Virginia which are impacting North Carolina, but you've eliminated those. So maybe think about how you're gonna manage that in the table.
Okay.
Okay.
Thank you.
Sure. Anyone else got any questions? I think we're good here. I see a bunch of people leaving, so I'll stop here.
Yeah, that's fine. Like the stadio.
And I'll stop recording.